Okay, in chapter 7.1 through 7.3 talks about the central limit theorem. And this is a very powerful theorem that if you're given a population with any distribution, it could be uniform, skewed, or whatever, you don't know that it's normal. Then the distribution of sample means, x bar, can be approximated by the normal distribution when the sample sizes are n greater than equal to greater than 30. Now, I have seen some books that say n has to be greater than or equal to 30. So the mean of all the values of x bar. Now again, this is a mean. Recall from the normal distribution, we were just given x. We weren't looking at means of x's. Okay, or means of the data we were given. We were looking at a specific value of x. Now we're looking at the mean of x bar. Okay, mean sub x bar. And it's just going to be the mean of the distribution. The only thing that changes here is your standard deviation. Now, the standard deviation is going to go from just simply sigma to sigma divided by the square root of n. And it's denoted sigma sub x bar. So your z-score changes to this. So this is a z-score for the central, if we're going to use the central limit theorem to approximate a normal distribution. Your z-score, instead of x, is going to be x bar minus mu. It's going to be divided by sigma divided by the square root of n. So just recall the normal distribution for the z was z is equal to x minus mu over sigma. So let's look at the differences here in chapter 7. Instead of x, we've got x bar, sample means, mu stays the same, and sigma, but we've got to divide by the square root of n. So a lot of people will say, well, how do I know whether to use the central limit theorem to find the z-score, or do I just use a regular normal distribution to find the z-score? If you're ever given a question that had in your homework that says we have sampled n equal 35, okay, then we know that and it doesn't say that it's normal. Then we know that the central limit theorem kicks in and says, hey, you know what? Since the sample size is greater than 30, we can use the normal distribution to do that. So it will not, when you're going to use the central limit theorem, it's not going to say that your distribution is normal. It's just going to say, you know what? Our sample size is greater than 30, and when we're doing, like I said, regular normal, it never gives us a sample size. So you see that sample size, you say, you know what? Man, that better be greater than 30. Then this is the formula that we're going to use to calculate our z-score. I hope this helps. Let me know if you have any questions.